Do the sets of data shown below represent inverse functions? Justify your answer. The first step is to look at our tables and compare the x of one table with the y of the other table and see if we have any of the same values. So looking at these two, we see that in both of these columns we have a 0, we have a 1 in both, we don't have a 2 in both, but we do have a 3 and a 4 in both. Looking at the y and the x, the opposite columns, we see we have a pair of 1s, a pair of 2s. We don't have a 4, but we do have two 8s and two 16s. So we do have many of the same values. Now let's look at the actual ordered pairs. Remember, with a function, if one table has the pair xy, the other table will have the pair yx. So looking at the first pair, we have 0, 1, and then 1, 0. So it fits so far. The next one, we have 1, 2, and we have 2, 1. Again, those are switched perfectly. We have 2 4s, the next one. We don't have a pair for those values in the right-hand table. We do have 3, 8 and 8, 3 that again are opposites, and 4, 16 and 16, 4. So based off of this information, so far it looks like an inverse function. We do have two other points that we need to look at though. So to do this, we need to look at the relationship between x and y in both of these tables and make sure that they are the exact opposite procedures for all of the points included. So to do that, let's look at these table values. So we need to find, how are these points related? How does 0 relate to 1? Well, looking at the y values, I immediately recognize that these are all multiples of 2. So, we can relate this to 2. They're also exponents, basically the result of an exponent with a base of 2. So if we look at 0 and 1, well, we know that 2 to the 0 equals 1. With 1, we know 2 to the 1 is 2. For the next one, we know 2 squared is 4. We know 2 to the third is 8, and 2 to the fourth is 16. So it does follow an exponential relationship. Looking at the other table, let's see if this works exactly the opposite. So if it's the opposite, well, we knew this was exponential. If we have 2, we know 2 to the 0. This time the 0 being the y value will equal 1. We know 2 to the first is 2. 2 to the third is 8. 2 to the fourth is 16. And lastly, we know 2 to the fifth is 32. So it does follow the same pattern except opposite, with the y being the exponent. Therefore, we can conclude that these are inverse functions because they do have the opposite xy values and the opposite relationship between x and y. Our final answer is the sets of data represent inverse functions because the exponential relationship between the independent and dependent variable values in the left-hand table and the exponential relationship between the dependent and independent variable values in the right table are related, and there are values in both tables that represent switch domain and range values of the functions.